Hello everyone, welcome back to our channel. Today we will present to you an in-depth guide on how the star-delta starter optimizes the operation of a three-phase induction motor. This will include the explanation of its working principle, the detailed wiring, its advantages, as well as applications. Without further ado, let's jump right in. When dealing with three-phase induction motors with high power above 7.5 kilowatt, the use of star-delta starter is essential. This method combines the star and delta configurations to reduce the starting current and torque transients, improving motor longevity. Let's explore the specific wiring methods for detailed explanation. Begin by connecting the three-phase power supply lines from the circuit breaker to the main contactor. Then connect these lines to the U1, V1, W1 terminals of the motor to control the flow of power to the motor. Introduce a second contactor for star connection, with the upper terminals for star shorting and the lower ones connected to W2, U2, V2. Simultaneous engagement of the main contactor and star contactor initiates the star connection, ensuring a low starting current for the motor, leading to a smooth and controlled motor startup. After the star starting phase, the transition to full voltage delta operation is crucial for optimal motor performance. Engage the delta contactor to switch the motor windings to delta connection, with the upper pins connected to the primary contactor and the lower ones shorted to the star contactor. Simultaneous engagement of the main contactor and delta contactor switches the motor windings to delta configuration, enabling full voltage operation for high power applications. Remember to implement proper interlocking to prevent concurrent engagement of star and delta contactors. If necessary, you can introduce a timer to control the transition from star to delta configuration after a set time delay. Overall, the star-delta starter operates on a principle where the simultaneous engagement of the main contactor, KM1, and star contactor, KM2, facilitates the motor startup at a lower voltage and current. Then, when the motor reaches a certain speed, the KM2 will disengage and the delta contactor, KM3, is enabled for delta operation, ensuring smooth acceleration. The star-delta starter offers several advantages for three-phase induction motors, including reduced starting current, better control of inrush current, and minimized stress on the motor windings during startup. Besides, the use of a star-delta starter contributes to enhanced motor efficiency and longevity. Another notable benefit of implementing a star-delta starter is the adequate coordination between the control circuitry and the motor itself for optimal performance. As discussed in the above advantages, the star-delta starter is ideal for applications where the required starting current is low with low starting torque being adequate, and where reduced voltage starting is essential for motor protection. Driving centrifugal compressors is a typical application for the star-delta starter, among others. And there you have it, a comprehensive guide on some key aspects of a star-delta starter. By understanding its working principle and wiring procedure, you're one step closer to optimizing your motor control systems. Ready to upgrade your motors and enhance industrial automation? Explore our wide range of motors, contactors, soft starters, and more at ato.com today. If you found this video helpful, don't forget to like, share, and subscribe for more insightful content on motor control and electrical engineering. See you until next time.